Hello, and we're back. We are looking at finding the linear equation given 2 points. Um, First, we're going to look at the finding an equation given a slope and a point. Um, so you probably remember y equals mx plus b, and this is our slope, which we're going to call m, and our point, which we're going to call x and y. So you can find the equation with this information, right? We just plug in what we know. Instead of y, we're going to plug in 1. Instead of m, we're going to plug in -2. And instead of x, we're going to plug in -3. And then we can solve for b, right? And so b in this case is -5. So our equation is y equals -2x minus 5. So that's our answer. Now, another way that we've talked about it is not using y equals mx plus b, but also we've talked about the idea of using slope-intercept form. Okay, so using that form, what we're going to do is y minus the y1, which is the number 1 right there, and then equals m, which is our slope, times x minus, and then it's -3 right here, but it's minus a negative, so it's going to be plus 3. So then that's also an answer. This is an equation for this point and this slope. If you want, you could change it into the y equals mx plus b format. You didn't have to. It doesn't say that you had to have it in slope-intercept form. This is what's called point-slope form. But you could distribute this, and it would be y minus 1 equals -2x minus 6, and then plus 1, and so it would be y equals -2x minus 5. Okay, so either of those is fine. Now the question is, what if we didn't have the slope? What if we have just 1 point, right? So if you look at it, this is going to, let's see here, right? This goes through -3, 1, and has a slope of -2. So it looks like this, right? It looks like this, okay? Y-intercept of -5, slope of -2. What if we had that same line? We know what the answer is, but we had just 2 points on it. How could we figure that out, right? So if we had just what is the equation of the line going through -3, 1, and 1, -7? What we want is we want that slope, right? So if we have that slope, -3, 1, 1, -7. Let's see, 1, 2, 3, 4, 5, 6, 7. So that's right there. So we know that it's this line right here, right? But we're trying to figure out what is that, what is the slope, right? What we're looking for is the slope. So it's, sorry, I'm being a little iffy with that line. So we know it's -2. And if you draw it, you can see that it's down 8, right 4, right? So you can see that it's down 8, right 4, which is down 8, right 4, which is -2. So we know what the slope is. The question is, without graphing it, could we get that, right? We know that the top number is up and down, and the bottom number is right and left. So if we think of it, the top number, remember the slope, it's the change in y over the change in x. Sometimes we use a triangle, a delta, for change. Okay, so if you look at these two y values, right, 1 and -7, what we want is this distance, right? We know it's down 8 because we look at the graph. But if you look at these two numbers, do you see that it's down 8? Right? From 1 to -7 is down 8. So it's 1 minus -7. You want that distance. So distance between two numbers is the minus. And then with the x's, it's the same thing. It's going to be -3 minus 1, right? So then that's going to be 8 over -4, which is -2. So that's how we find that slope. Okay, and then once we have that slope, we can plug it back in to the previous equation, and we're good.